Hi folks, continuing from the last short video in which I discuss with you a project that I am doing for my power electronics and electromagnetics lab, and this project is about programmable DC variable output test bench power supply, high power. I mean, it can operate from 0 volt to 80 volt DC, and output current can be from 0 ampere to 20 ampere, and approximately it is 1 kilowatt power supply. So it consists of two boards, secondary board on the upper side and the primary board on the bottom side. And as you can see, the almost all the components have been stuffed on it. A few components remains to be done, and they will be installed as the project advances to its testing and fabrication stage. So this is the secondary board, and you can see almost all the components have been stuffed, and this is the primary board. You can see some relays on it, then capacitors and ICs, sockets, some other components, and here you can see the semiconductors, MOSFETs, double diodes, etc. on the heatsink. And on this side you are seeing some empty space. Basically here two transformers, ferrite core transformers would be wound and installed on this side, one on this side and one on this side. So because the current would be of high magnitude, I am planning to use the copper strip to wind the transformers instead of these copper wire. As you can see a sample like this is a copper strip. Just like this, I would utilize the copper strip so that high current can be passed through the transformers without much heating up. And then I am also working on the casing, 3D printed casing of the programmable DC variable output test bench power supply. The 3D printing and 3D design of the casing is under process, and on the casing high quality correctors would be installed, and then there would be a graphical LCD display, as you can see right in the picture. So this graphical LCD would be installed on the 3D printed body. Then there would be a keypad that would also be installed, so that you can program the test bench power supply. I have some options available at the moment. This is a simple 4x4 matrix keypad, and this is also 4x4 matrix keypad, but this is the capacitive touch keypad. So let's see which option I choose. And this is the power socket connector that would be installed on the back side of the 3D printed body. so that power cable can be plugged in. Then although you can configure the output voltage and current rating using the keypad, there is another option that I am installing on the 3D printed body as well, and this consists of two rotary encoders, and these rotary encoders would be used to adjust the voltage and current reading of the switching power supply. So then a fan will be installed on the back side near the heatsink, so that heatsink remains within operating temperature and doesn't much heat up. So there is some other extra work that need to be done. For example, as you can see, although the components are almost stuffed, but if you see on the back side, then it is a single layer. This is a single layer board, and due to the single layer board, it was not possible to create all the connections on the back side. So some connections you can see they are already created, and the remaining connections would be done manually using the prototyping wire by connecting the different points, concerned points. So similarly for the secondary board, the same situation. It is also a single layer board, and some connections have been done, as you can see their tracks, and the remaining connections would be done manually using the prototyping wire. So this is a very careful and very time taking and milestone of correcting the different points using the prototyping wire. Once that is done, then the power supply would be ready for the testing. So guys, this was our today's short video. So stay connected and thank you very much.